Hi guys! Good day! I am Glenda Postrado from BS Ed Math 2A, and today we are going to talk about Chapter 2, Lesson 2. After we've learned how to organize the data into a frequency distribution, which is defined as an organization of raw data in table form using classes and frequencies, we can present them in graphical form. First, let us define graph. A graph is a picture that represents data in an organized manner. And the purpose of graph is to convey the data to the viewers in pictorial form. It is easier for most people to comprehend the meaning of data presented graphically than data presented numerically in tables or frequency distributions. This is especially true if the users have little or no statistical knowledge. Statistical graphs can be used to describe the dataset or to analyze it. Graphs are also useful in getting the audience's attention in a publication or speaking presentation. They can be used to discuss an issue, reinforce a critical point, or summarize a dataset. They can also be used to discover a trend or pattern in a situation over a period of time. So let us now proceed to the three most commonly used graphs in research: the histogram, the frequency polygon, and the cumulative frequency graph or ogive. The histogram. The histogram is a graph that displays the data by using contiguous vertical bars, unless the frequency of a class is 0, of various heights to represent the frequencies of the classes. So, let's have an example to understand how to construct a histogram. Construct a histogram to represent the data shown for the record high temperatures for each of the 50 provinces. So as you can see, we have here the class boundaries and frequency. So in constructing a histogram, we need 3 steps. First, draw and label the x and y axis. The x-axis is always the horizontal axis and the y-axis is always the vertical axis. Next, represent the frequency on the y-axis and the class boundaries on the x-axis. So, in this particular example, we have temperature. Step 3. Using the frequencies as the heights, draw vertical bars for each class. So one thing we should always remember in constructing a histogram, bars should always be touching. Because like what we've said earlier, a histogram is a graph that displays the data by using contiguous vertical bars. First, between 99.5 and 104.5, we have 2. Next is 8 in between 104.5 to 109.5. And 18, 13, 7. Between 124.5 to 129.5 is 1. And last is also 1. So that is how we construct a histogram. As the histogram shows, the class with the greatest number of data values, which is 18, is in between 109.5 and 114.5, followed by 13 for 114.5 to 119.5. The graph also has one peak with the data clustering around it. Next is the frequency polygon. The frequency polygon is a graph that displays the data by using lines that connect points plotted for the frequencies at the midpoints of the classes. The frequencies are represented by the heights of the points. Example. Using the frequency distribution given in previous example, construct a frequency polygon. Unlike in histogram, when we construct frequency polygon, we need 4 steps. First, find the midpoints of each class. Recall that midpoints are found by adding the upper and lower boundaries and dividing by 2. So here, first is 99.5 plus 104.5 divided by 2 is equal to 102. Second, 104.5 plus 109.5 divided by 2 is equal to 107. And so on and so forth. So we have here our midpoints. Step 2. Draw the x and y axis. Label the x-axis with the midpoint of each class, and then use a suitable scale on the y-axis for the frequencies. Step 3. Using the midpoints for the x values and the frequencies as the y values, plot the points. So, we just need to look at our midpoint, which is in the y and the x-axis rather, and our frequency on the y-axis. So in 102, we have 2, 107, and we have 8, 112, 18, 13, 7, 127 with 1, and 132 with 1. Lastly, connect adjacent points with the line segments. Draw a line back to the x-axis at the beginning and end of the graph, at the same distance that the previous and next midpoints would be located. In constructing a frequency polygon, we should always remember that it always starts and ends on the x-axis. So, it would go here. Then here, here, here. Yeah, we just need to connect adjacent points with line segments. And it would always end on the x-axis. So that is how we construct the histogram and a frequency polygon. Once again, I am Glenda Postrado from PS Ed Math 2A. Thank you for listening. The next topics would be discussed by Carla Joyce Puno.